Now, contrasting parallel circuits to series circuits, parallel circuits have multiple paths for the current to flow. Right? So in this particular circuit, we can see there's 3 paths of current flow, one for each light bulb or each load, so to speak. Now, the voltage here is the same as the voltage of the power supply. So this is a 12-volt power supply, so the voltage across each one of these loads is 12 volts because it's 3 separate loops. So now what changes here is the current through each loop is different. It depends on the resistance in the current. So the resistance in this case of each of the bulbs or each of the loads. Now the great advantage of a parallel circuit over a series circuit is if one device goes out or there's a short circuit, it's only that loop that's affected, not the other loops. So we can see here we've got a bulb out right here, right in the middle loop, but this left loop and the outer loop here, the right loop, yeah, the bulbs are still going strong, right, because they don't lose any current. So yeah, so I've made a note here. Household, commercial, institutional, industrial wiring. So any building that you're in, whatever it happens to be, it's all parallel circuit, right? You turn a light off in your room, the lights in the rest of the house don't go off, right? Or you have a light bulb go out, right? The rest of the lights in the house don't go off. So yeah, so it's a great advantage over a series circuit. So what we'll do now, we'll use Ohm's law to do some parallel circuit calculations. So those 3 bulbs we had in a series circuit, now we're putting them into the parallel circuit like we see on slide 38. Still the same 12-volt battery. We're going to determine the current through each bulb. Remember now, the voltage across each bulb is the same as the voltage of the power supply. So the voltage across each one of those bulbs is 12 volts. So let's take a look at our solution. Okay, so again, bulb 1 is a resistor, right? In other words, it brings resistance into its loop. Same with bulb 2 and bulb 3, so we represent them again as R1, R2, and R3 respectively. Any load in any circuit always has resistance. There's no such thing as a resistance-less device in a circuit. Okay, so now we want to know what the current is across each one of these bulbs, or through each one of these bulbs rather. So we know from Ohm's law, I equals V over R, so I1 equals V. V is always 12, right, for this particular circuit, over R1, and we know the resistance for the first bulb is 24. So we get 12 over 24, which is 0.5 amps. So that's the amount of current going through the first bulb. Second bulb, we do the same thing, except now we're dividing the voltage by the second resistance, which is 16, and we have 0.75 amps, right, going through bulb 2. And then our third bulb, right, R3, that resistance there is 10, so our amperage there is 1.2 amps. Right, so notice, same voltage rather, different resistors though, so different currents. And this is in a parallel circuit. So, an important note here, so the sum of the currents in a parallel circuit equals the total current in the circuit. So here if we add these 3 currents up, one from each loop, our total current in the circuit is 2.54 amps.